Good afternoon, everyone. Thanks for joining us on a special seminar presentation. It's Monday afternoon. We usually do these things on a Friday, but it's good to have two in the same week. Today we have Jonathan Beaudoin. I think he's more commonly known as JB to everyone, so that's how they've been addressed from now on. JB has a PhD in geodesy and geomatics engineering from the University of Brunswick and a bachelor's in geodesy, geomatics engineering, and computer science, also from UNB. After finishing his PhD, he came to CCOM and did his research in the field of echo-sounding uncertainty associated with oceanographic variability, seabed backscatter processing, and improving best practices in multi-beam echo-sounder fleet management as the principal investigator of the NSF-funded Multi-Beam Advisory Committee. Long sentence. After nearly 4 years at CCOM, he returned to Fredericton, Canada in 2013 to work for QPS, where he's the chief scientist and project manager for FMGT, FM Midwater, and the new program Chimera. Welcome.
Thank you. Mo was going to be here with me originally, but he couldn't make it. So we were planning this wonderful, kind of cage match presentation. So I'll try and just do it on my own. So I think this is going to be a tradition now, the leap year presentation. Every 4 years, QPS comes and gives a talk about stuff. So this is the first one, so mark this in your calendars. So I'll start in, and because I'm Canadian, I'm going to start my presentation by apologizing. If any of you were at the NOAA Field Procedures meeting earlier this year in January, this is a longer version of that talk, and maybe I might use some of the same jokes and analogies. Just bear with me, it's a longer version. What's that?
Longer jokes.
Longer jokes, yeah, more tiresome. I'm going to start with this little small story about how I sent my daughter out to start the car, because it's winter and it's cold, and that's what we do in Canada. It's cold, and if you have a kid and they're bugging you because it's a small house and it's winter, you get them to go outside for silly reasons like starting the car. And she went out and started the car, and she likes to sit in the car and listen to the radio. So she sat out there for 10 or 15 minutes. And, well, of course, when we start the car in the winter, the heat seaters are on full blast, and the heater's going full blast. But she didn't start the car. She just turned the key to here. And so she came in 15 minutes and said, "Daddy, the car doesn't work anymore." And I went out and went click, 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 click. She killed the battery. So I gave her a seemingly simple task. I thought she was just going to use the remote starter and let herself in, but she decided to be a big girl. She's 10. She went and started the car that way, and it didn't quite work out. Anyway, it could have been worse. Had I sent her out 100 years ago, this is how she would have started the car, and then you'd run around the side and jump in it before you roll away until the bob brake embedded the brakes. That was how cars worked. And it's getting better. I mean, cars are getting easier to use. Now you can get in the car, and you can do that. You can push the button. And if I got a new car, I'd probably have that. We wouldn't have that situation. But this sets the stage. Technology does this. It has a natural progression. We have a new idea, and it gets better and easier, and then it gets to the point where back then you had to be a mechanic. You had to be an engineer to operate a car, to own a car. And if you couldn't do those things, you had to buy people to do that for you. Not buy people, hire people. Now anybody can drive a car, and if we look at what Google's doing, children will be able to drive cars. You just get in, and it takes you to where you need to be, and you get out. That's kind of a natural progression. And this sets the stage for what we're talking about today, which is hydrographic data processing. It can be a hard thing. Cars have been around for a long time, and it's getting easier and easier and easier. Anybody can do that. But we're still kind of in the early stages of digital seabed mapping, where we have data that's recorded on computers and it's processed by software and expert personnel, and then we look at that and we make it better and generate products. And that's a complex procedure that generally there's a pretty high barrier to entry to that. You have to almost be an expert at all of the system components in order to jump in the field and get good data and to reliably do that and to generate high accuracy products. But it's hard, it's true, even for people who really know what they're doing. So you go out and you make mistakes. You catch a red eye, you get off the plane, you get on the ship, you're doing a patch test in 6 hours, and you make mistakes. They happen over and over, and even when you really know what you're doing, project after project, you're rolling the dice. Eventually you'll make a mistake, even if you know what you're doing. So that's what we're trying to talk about today, is that a lot of the frustrations really is that the human operator is still connecting all the pieces It's a complex workflow. There's a lot of pieces that go into it. You measure A, B depends on A, likewise. And when you need to get to your final end, you need to understand this flow chart. And when you make adjustments to it, you need to understand, where do I have to go back? If D depends on B, if I have to step back, I need to trigger this to update everything. And really, we're kind of at this stage, and maybe not this bad of analogy, we're still turning the crank on our data to get our results. And we need to get out of that mind frame. And so people that know me, people like Glenn, where are you?
He knows you too well.
He knows me too well. It's time for a paradigm shift. I swore at one point in my career I'd never say things like paradigm shifts, but it's time for a paradigm shift. We need to stop working that way, especially when we consider the dependency diagram of all of the things that we observe, and then the final output is what we care about at the top, the reduced depth. Now this is a slide that Brian graciously let me use. This is for uncertainty modeling, but it pretty much captures the dependencies of all the pieces that we can observe. Our observables, the processes that need to happen to them, and then the final thing that we really care about at the end is the reduced depth. And we need to know all of this. That needs to get done. We can't make that go away, but we can make it easier. So humans make mistakes along the way. There's all kinds of spots where you can make mistakes. So there's lots of sources of human error in the system. First of all, I have vessels, and depending on the software I'm using, there's different coordinate frames. You know, is Z up or down? Which way is X and Y? Do I have a left-handed or right-handed coordinate frame? And if I get on a ship and I've just spent a long time flying and I'm tired, and someone hands me a PDF report from the surveyor, and it's a one coordinate frame, and I have to take those numbers and mentally transpose them into another coordinate frame, I'm going to make mistakes, even if I know what I'm doing. And there's procedures in place for that. You get a couple or three people to do that same thing, and you compare your answers at the end. You know, offset bingo, I think is what one person called it. We're trying to get to some different coordinate frame. This is where people make mistakes. We're just not good at stuff like this. There's other sources of human error. Managing the process. When I bring data in and I have to convert things and apply things and recompute things, and if there's a sequential sequence that must be followed rigidly, what happens if I get that sequence wrong, or if I forget to trigger things? And people deal with that in the field. You see these line logs in a spreadsheet where there's a line number, and then we're building a checklist. You know, airline pilots take off planes regularly, safely, because they use checklists. Checklists work. Well, here, I've copied my data, I've converted it, I've applied it to some tides, I did some sound speed, I've computed the propagated error, blah, 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 blah. We do that over and over, and then after you get to like week 4 in a cruise and you're doing this, you just see people just typing X's and then don't even. Checklists only work if you actually pay attention. So they can work, but they're also fallible. So things can fall apart if I bring in ancillary data and I fail to apply it to the correct data file. So if I bring in tide data, the correct soundings, but I don't apply it to the correct files. There's other examples. If I change my processing configuration, if I'd like to use GPS tides instead of regular tides, if I can bring all the data there, but forget to apply that. Or I could just not trigger it at all, or for the wrong files. There's a lot of room for human error. And what's that cost? That's the point of this presentation. Is part of it is this interesting idea, and I'd like to maybe talk about it with a cup of tea with Brian, is there's human TPU. We worry an awful lot about our total propagated uncertainty, the GPS antenna, all the lever arms, and my multibeam, and my angle uncertainties, and my sound speed uncertainties, and there's my sounding with its total propagated uncertainty. I can have great measurements and great estimates of the uncertainties in each measurement and come up with that. But what captures the fact that I might have, you know, 1 time out of 20 forgotten to apply my tides? There's a 5% chance that could happen. So there's human TPU. Depending on the operator's skill, how tired you are, things like that can play. There's a lot of room for human error, and that can compound with each mistake. What does that actually mean? Well, you can have one outcome. You can have really, really fantastic measurements, but your output products really don't reflect that. And if your skill set's not quite high enough, you may not even realize that. You may be delivering stuff that's not good, and you may not realize it. If you're lucky, you'll recognize that later. Maybe you don't get burned career-wise. You learn from your mistakes and you move on. The second potential outcome is you might have a great result, but it took a lot of time, or a lot of people, or a lot of money to get to it. at the Monroe Field Procedures Workshop, they said it takes several hundred days to get a chart, data from the ship to the chart, because there's a lot of people in that process that are doing double checking. These are necessary things. So what we need to do is we have this spectrum of working difficultly. We need to get to a spot where we can work smarter, not harder. So we need to stop thinking that way and start thinking we need something with an easy button. I think Larry's called it. A friend of mine, when we were learning mapping years ago, he said, I just want a button that says make map. And that's really kind of what we need to do. We have the measurements. We know how they need to be put together. Just give me a button that says make map. And so this is what we've done at QPS is, in case you're wondering where I've been for the last couple of years, I haven't been down here a whole lot, so we've been spending the better part of 2 years building a product to really address this key weakness in the market right now and how we work in this field. There is no easy button, and I think that we can get to a spot where we can do that for people. So I'll just step back for a second and say, what's a chimera? Maybe you're familiar with Greek mythology. It's one of these things. It has a head of a lion, head of a goat, head of a snake. And I think Aaron was the one that came up with that, I was told.
It's a long story, involves beer.
A long story involves beer. When we first started thinking about doing this, we realized we have an awful lot of technology, and if we can just put it together and present a nice and pleasant user experience, we could have something that does this. And really, if I could stretch the analogy a bit, the lion was the Quincy Hydrographic engine. So Quincy is our software product that does acquisition in real time, does real-time integration, ray tracing, georeferencing, vertical and horizontal, and it also calculates TPU. And there's an engine in there, and we took that engine out, put it on the floor, and said, okay, what can we do with this? This is an amazing piece of tech. We have the Fledermaus 4D visualization engine, which handles large data volumes in an elegant manner. And then finally, there were a lot of lessons learned, and there's a lot of core technology, FM Geocoder Toolbox and FM Midwater, that lets you multi-core data process really intelligently and schedule tasks and buffer it so that you can get the most out of your computer. And these are the three pieces of tech that we had sitting in the company when QPS and IBS became one. And Chimera was the natural thing. So look, what do we have here? What can we bring to market? And that was it. Let's take these things out of each individual application and make a new application. And then really the fun part was spending a year figuring out how do we make this complex process easy? How can we make this easy button? So this couple of nice screen grabs. So this is for, I have to say these things. We can read in most of the data formats that you're familiar with for multi-beam mapping, all the ancillary formats that you're familiar with, and then we can export to the most common formats. So the things that you're used to doing with bathymetric data, we can do that as well. And we have a Fledermaus, the middle showcase screen, 4-dimensional view. But you can do hydrographic processing in this environment. So there's a couple of key things that went into designing the easy button. And really it was recognizing where does a human bring value to the process and where does a computer bring value to the process. And let's take those apart and make sure we don't mix them up. And so the examples I gave before, like transcribing measurements from one coordinate frame to another, or figuring out at what stage of the processing am I and which stage do I need to get to next, and then how to adapt that if I bring new information. Let's just be honest, we are rotten at doing that. People don't do that well. You have to put a lot of QA procedures in place to be able to do that. Where does a human bring value to the process? What we're really good at is looking at data and just saying, oh, that looks funny. We can do that. Computers may eventually get to there, but for now, we're much better at that. So let's isolate your eyes-on target aspect of your data processing to be that. Managing the recipe of what you want done, we're good at that. The computer may be able to figure out what you want to do with the data if you just throw it in the hopper and let the machine run. We're much better at configuring it to tell it what we want out of it. And also, from an engineering point of view, if you're out doing C acceptance trials or shakedowns, we're pretty good at figuring out the causes of errors if we're given the right tools. Computers aren't so good at that yet, although there's a lot of people working on making that automated. So those are the basic ideas, and what we've come up with is a couple of things: a guided workflow, So really, we want to let non-expert users get to mapping products, typical mapping products, without being an expert. Everybody should be able to show up with a hard drive of data, and within a matter of minutes and a few button clicks, get to a map. We shouldn't put processes in the way for the sake of the process. You should be able to see your map right away. And then another aspect of this is a dynamic workflow. Is that whole dependency diagram I showed a few slides ago, is that should just be put in a box. You can open the box and look at it if you like. But if you don't care to know what's in there and you just trust us, you can put numbers in, answers come out, and then you can play with that and see the results very, very quickly. And you don't ever have to remember what needs to be done. You just need to remember that some processing needs to be done. So if you bring data in and make a map, and then bring in new ancillary data, it should just get all hooked up and it says, hey, I'm going to reprocess your data. Did you want to do that now or later? That's really all you should have to do, not remembering if I bring in this kind of tide or this kind of GPS thing, what needs to happen next? No, no, no. That's all hard-coded in the software. So you don't need to worry about those things at all. So I had this wonderful eureka moment in my hotel room over the weekend. It's a guided workflow. It sounds like something the sales department came up with. What is that? I'm going to give you an example of a guided workflow that I discovered in my hotel room over the weekend. I wanted to make a cup of coffee, and I'd never used this machine before. When I do something, the next step in the action is implied for me. I put water in there. I didn't know how to use this, and I mean, it's a coffee machine. Admittedly, this is pretty easy to figure out, even for me. I close the lid. The little light goes on. Hey, you've got to do this next. And this thing is guiding me into what needs to happen. Oh, I guess I push that next. And I have a cup of coffee. That's a guided workflow.
So the first time I did that, I put the water in the first one. The coffee thing in the second one. It doesn't tell you that.
I'm not going to make you watch this brew my coffee. It took a little while to heat up. I assure you that I did get a nice warm cup of Hotel Delicious great coffee out of it at the end. And then actually, after I had this clever eureka moment and realized it was perfect for this talk, I went back and realized, because I'm a man, I didn't notice there were instructions. Yeah. The hotel also, although be man, they won't see that. I'll put a card here. So anyway, that's a guided workflow. If you need to do things and you have one thing to do in there, we should guide the user. You don't need to be an expert to make a cup of coffee. You shouldn't have to be an expert to take data that's reasonably well acquired and put it in and get a map. And that's what a guided workflow is.
So it assumes that there is no branching.
No branching.
It's just sequential actions.
Well, that's part of the design. What do most people want to show up and do? And let's offer a solution to them. But there's ways to get out of that guided workflow and divert from that if you need to. If you already know what you're doing, you can divert from that. If you've never done it before, that's the experience we're trying to streamline and make simple for people. So here, I'm going to do a live demo here of a guided workflow. So there's a screenshot of where we'll end up at the end of this. So we start Chimera, and it's the usual thing. You start anything. Do you want to make a new project? Say, number 1. And then now the software guides you. You create a new project. I'm guessing you want to add some data to that. And if you don't want to, you can go and do other things. But if you really don't know what you're doing and your supervisor gave you a hard drive full of data, that would guide you to there. Of course, I missed the question. It quietly goes away. I'm just going to hit the button. You can all do this. You can do this the long way if you know what button to hit, or you can answer the questions. So I'll add some files. And then it does things. So it's slowly adding files here, and as it adds the files, it pulls all the ancillary information out, and the map's slowly growing in front of us. We say, okay, I see track lines, that's good, that looks like the survey I just conducted. Again, another step in the guided workflow. I'm going to put the coffee and the water in the back, stage 2. So you probably want to make a map now. Like, yeah, I do want to make a map. I have a map that took 4 clicks. That's really, if the data is well integrated, all of the information's in there, you shouldn't have to jump through a bunch of hoops. I just want my map. Show me my map right now, and then I will identify if I need to do special things to that to make it better. It should be that. So that's a guided workflow. So I'll get back to this. So transcription automation. This is something else that Chimera does for you. It's realizing that people are really horrible at doing mental math and taking a surveyor's report in feet, turning it into meters, and switching coordinate frames from one to the other. This is where we always mess things up. So maybe you knew this or not, but most of the modern multi data file formats have all of this information in it. So what we've done from the ground up with Chimera is to take every file format that we wanted to tackle in the first release and say, let's get everything out of there, as much as possible information. You should not ever have to type anything. SVPs, you should not ever have to go find those files from the cast. They're in your multi file. Here it is. The vessel configuration, same thing. Get rid of those pieces of paper. It's in the file. If you set it up in acquisition right, and you made sure it was right in acquisition and you confirmed it, some files have tide in them, for example. You can bring that in. The processing configuration. Is this particular file configured to use tide or GPS correctors for height? Or do I have 2 motion sensors and I've designated that the backup one is I want to use as a primary? A lot of that's encoded in the file. We figure that out. And these are well-known data standards. This is all codified in there. So a lot of people that look at that and figure out how do we take that information and put it into the experience so you don't have to worry about it. So Chimera does all of that. And the point is, if you spend the time getting it right in acquisition, you can get to Chimera and you just drop your data in and then you get a map. And you don't have to do any more math. There's no more mathematical processing. You might want to bring in some other correctors, but you can get straight to work. That's stuff that you're good at, data validation. So I'll give another quick demo. So here, automating transcription. I'll have files. So I've got data from a Kongsberg EM2040 and a Reson 7125. This is from the shallow water survey data set in the UK this past year. So I skipped over the details last time, and I'll go through some of what's happening under the scenes, behind the scenes now, make a map from that. But first, I'll just bring in the second data set from the Reson. The Reson S7K file doesn't have a vessel name in it, so these are one of the instances where Chimera will present you with one thing that you have to type in. We'll call this Reson vessel. And that comes into the app, and there it all is. Let's just trigger the processing. Oopsie, not that.
Does 7125 have lever arms and offsets?
It can. Yeah. Oh, sure.
Guided workflow.
Here you go. Okay, so there, I brought in data from 2 different kinds of vessels, 2 collected at different times with 2 different data formats, and boom, boom, I've got 2 maps. If my job was to take a hard drive and to make a report for my boss, and all of the different kinds of system artifacts observed by the different multi-beams at the shallow water survey data set, I'm ready to get to work right now. That took a few minutes, a few clicks. If I wasn't talking, I would have been done 2 minutes ago. So you can do that. I've got, and let's rename this. So without really thinking about the math or the offsets or the tide or anything at all, I've got 2 maps, and I can compare them very easily here. My job is to do analysis and comparison. I'm getting right to work. That's what a human is good at doing. The rest of the stuff, well, if you want to, you can fix that stuff if you got it wrong in acquisition. Let me just regroup these by vessel. I can organize my vessel data, my sound speed data is there. Oopsie. So I can organize it all. I can bring in different types of information, different sensors, different platforms, different data formats in the same project, and it just sorts it all out. So what kinds of things get pulled out programmatically for you? The vessel editor. I'm just going to show you some of that. I mentioned several slides ago, if this information's baked into the files that you brought to Chimera, it extracted it and it put it here. You're not held hostage to mistakes you might have made in acquisition. If you did make a mistake, for example, you forgot a negative sign here in acquisition, you can go fix these things if you need to. But if you don't need to do that, or if you trust the person that gave it to you, or maybe you did it yourself and confirmed it, you just get straight to work. If you did your job right and we've done our job right, you shouldn't have to come in here at all. But if you need to, it's here. It's not like it's a black box and you're stuck with the settings in acquisition. So I can see for the resaw, there's the installation angles and lever arms and the different kinds of sensors there. The same information. Another interesting thing is the sign conventions. Each file format has a different sign convention. An S7K file, heave is positive up, for example. But if I look at a Kongsberg system, heave is positive down. That's something that anybody who uses those files day in and day out knows. That's just figured out and encoded in the vessel configuration file. You're not going to make mistakes figuring this out on your own. It's hard-coded during the import. I think that's pretty much it for this part. Oh, it thinks I made a change. Back here. So what else are humans not good at? Is processing state management. If I bring in information that's going to improve the data that I've acquired and make the map a little bit better, if I bring that in, what kind of processing needs to happen? If we think of this dependency diagram, if I had a result and then I showed up 2 hours later with new information for any one of these input spots, what kind of processing needs to get done? And if you've taken the mathematical classes that teach this, you could say that. You could know that, and you would know if this was your system that described it, you would know if I brought this on, yes, push this button, then that button, and then that button, and then that button, and then everything updates. But that's hard to remember. You have to have that loaded up in your head all the time. What we're trying to get to a spot is where when you do and commit an action, there's an effect that will eventually happen. All of that stuff needs to be in a box, and you can't break it apart. This should be an atomic and an indivisible task. If I do something, the action must follow. You can delay it. Maybe you want to trigger 14 hours of reprocessing just as you're getting up to go home for the weekend. You can delay it, but we make sure that you don't forget. And so this is something that's built into Chimera as well. When you bring new stuff in, it just figures out what to do. So that's this third demo, is processing state management. I can never remember if I'm supposed to say processing or processing in the US.
Process.
Process.
Depends on the latitude.
Oh, okay.
Soon they forget.
So I'll add some files. So some of you might recognize this data. It was collected offshore around here during some fish traps kind of aquaculture thing going on. So there, we have some data. I've made a map, and let's say I show up and okay, obviously I've got some edges here. So the standard Flater mouse tools are in here as well. I can take profiles. I say I've got a bump about a decimeter or two along that profile. It looks like I need to apply some tide data. These files don't have tides in them. So the gears icon is where you go to change anything that is inside that box. There's one spot to go. You go to here, and then this is where you control the switches and levers if you need to. If you don't need to, you can stay out of here if you trust everything that was done in acquisition. Some file formats are a little easier to do that with than others. If I go to my vertical referencing, right now my vertical referencing is set to none. I have no time. I'm not vertically referenced to anything really. I can bring in some GPS information, or I can bring in some tide. So let's bring in some tide and see what happens. Now these are some tides that I've modeled because I wasn't involved in this project in 2004. I just punched in the lat long and date range into a tidal model and got a time series. So it figures out, oh, it looks like you have a text file. It looks like that's the date time field, and that looks like it's the tide field. So I look at that and I confirm it. Yeah, that looks right. And just for the sake of metadata, I'll give the station a name. If I want to punch in some lat longs in there, I can, or I can just click OK. And then I click OK, and then watch what happens. There's the tide, but now all of these files are marked as needing to be updated. I've caused something to happen. The effect is that these need to be reprocessed. I'm being prompted to reprocess them. If I want to pack up and go home, I'll hit no. If I want this to happen now, I click yes. What will happen? I'll just click no, because I need to talk a little bit more. You can still figure out what needs to get done. These files need to have tide applied. They need the Z value to get adjusted. I don't need to re-ray trace. I don't need to recompute TPU. I just need to adjust the tide value. If you want to know what needs to get done, you can. Or you can say, I trust you guys. Just do what needs to get done. Update that, and then update the map. That's all linked together. I caused something to happen, and a couple of clicks away, the things that need to happen, and the map updates. Now, this is a tide model that I brought in. It didn't give me a great profile improvement, but there's that. Aaron, help me out. Is it recompute? Yeah, there we go. Now that step is a little bit less. So I brought tides in, I applied it, I updated everything, and I get that immediate feedback like, oh, that doesn't look quite as good as I'd like it to look. Maybe I should go to the NOS website and download some tides. That was a few clicks. I brought it in. I see that it didn't quite have the effect. I'm going to work a little harder to make that better. I need to do something, and I did that rather quickly. I didn't get lost in the process in the weeds. I just made the change, saw the effect. So dynamic workflow, that's another one of these things. It sounds like a made-up, marketing kind of term, but it's a real thing. It's that processing state management I just showed you, but it's live. When you make changes, everything is wired up. If you want to, it will just update all of the things that need to get updated. So you don't need to push things through. You can make processing configuration changes and quickly and easily tell, did I make things better or worse? And if you can shorten that time, you can kind of train yourself a little bit. I can bring in some GPS stuff and apply it. Does my height solution make it better or worse? That didn't seem to do the trick. Maybe I should fall back to tides. Bring in the tides, recompute. Okay, that looks better. I'm happy with that. If you can make that feedback time smaller, it's much more easy to figure out what's going on with problematic data sets and get to what you really need, which is good data in the end. We want to get all of the pieces out of the way and just let you get to work. So that, again, just becomes this. And really, the dynamic workflow is as you change the inputs, you can watch the output, and you can learn things about what needs to get done. You can even train yourself on what's happening. So I'll go through another demo here. Some other niceties that are built in is that we try and catch things for you. This is telling me that all of my vessel offsets are all 0. Maybe you did that on purpose. That's a bit of an unusual setup, but maybe you meant to do that, but you should know that. Would you like to go do something about that or not? Here's your chance. Start that process. So what I've got to bring in here is actually, let's just let that finish up and go to the map. So I get a map. can look at it. I can see some weird stuff going on. Like, what's this all about? That's kind of strange. Let's look at that. Oh, I need to move this guy. So I know swath editing is a pretty old school way of cleaning data, but it's a fantastic way to look at what your data is doing in a multi-beam reference frame. It lets you see wobbles and engineering problems in a way that area-based editing doesn't. So I'm coming here to figure out what's going on. This little line of soundings there, I can see there's something peculiar here. I've got gray soundings, that means they've been filtered. And I've got this one little edge here. Oh, that's kind of strange. Zoom out. And just because I know what to do, that looks like sounding have been filtered, but not quite enough. Maybe I forgot to be on the edge. Maybe the computer just wrote this dialogue and I have to count from 0 instead of 1. I can click OK. Oh, okay, that seems to fix that. That was just a little mistake during acquisition. So I can get out of here. I'm not going to bother to do that for that file. It affects all the files. So I can grab all of these, hit the gears, and say for all of these guys, let's just fix this. Yeah, and then recompute everything and then update the map. Bing, there you go. That's all cleaned up. Now let's say I want to do a little bit of filtering. Some little warts and pimples on the seafloor here. So I can select this guy. We've got a couple of simple filters that we've got from our Quincy software. Apply spline filter. This is where you get into the specialist stuff. If you know what you're looking for, you can go get it and use it. But if you didn't know that, you eventually find it. It's not part of the mainstream processing. So it's not part of the guided workflow. It's a bit of a specialist thing. So that cleaned that up on line number 7. I'll just do that for all of them. The map updated. And Val, you're not allowed to ask me about the spline filter after.
Damn it. Is there a way to see the before and after of that, applying that filter?
I could, yeah.
Okay.
This is a dynamic surface in that the sense it updates. You can't unhook it from the data. If the data gets changed, the surface updates. I could pause it. For example, I want to go home. I don't want to regrid for an hour. But for the most part,
You can save the.
yeah, you can take a snapshot as like a Flated Mouse SD file.
But if there was an easy way to say, all right, I want to know what this filter did, just
Yep.
a flash.
Well, actually, let's do that. We'll do that right after this. It's part of the CAN demo. So I've made that cleaner.
Can you back up that one process you just did, that last process?
Yep.
See, oh, I didn't like to do that at all.
You can, yeah. Where's that again? It's in here somewhere.
Filtering.
Clear spline.
Clear spline.
Oh, clear spline, okay, there you go. Yeah.
That's a special kind of spline.
Yeah, the clear spline. Yeah. So what I'll do is this particular data was shot with RTK, so it has really good vertical referencing from the GPS. And when the files were brought in, we detected that GPS was configured to be as the vertical source. There's some under the hood geodesy that's happening to convert to the local water datum. What I'm going to do is bring in some tides and just see what's going on with tides. So I'll make a static surface of this. So this is a way to make, because you're asking, Roland, a before and after. So this is the data processed using vertical referencing from GPS. I'm going to add a tide file. This particular tide file is a standard format. We can detect an awful lot of the station metadata in there, and it pre-populates it. If you don't like it, you can override it. And that gets all pulled in here. We brought it in. Let's just scroll down a bit. That looks like tide. It covers quite a span of time. And it's telling me, hey, all of these files need to be updated. Did you want to do that? So yes, let's do that. It's going to update the dynamic surface even though we can't see it. The surface cannot be uncoupled from the state of the data. It has to be updated. That's part of the design. But what we'll do now is make another image. So I can flip between the two and say, I brought in my tide and something kind of silly happened. That's not quite right. This is where a human brings value to the process. I brought in information that I expected it to make it look at least as good, maybe a little bit worse. GPS is usually better than tide if it's all well collected and controlled. But in this case, it's not. Something goofed up. So let's just turn these off and go back to the dynamic surface, which of course is updated with the data. That's always updating in the back if I make a change. And so we can use the UMB John Hughes Clark wobbleometer techniques. I have a file here. Say, oh, I've got some weird kind of wobble, but let's just think about it from an engineering sense. I see profiles there. I see a wobble. It's on the order of maybe ½ meter. You can use the multi-plot tool to start doing some engineering kind of questions, just a basic troubleshooting before you pick up the red telephone and call it an emergency. Makes sense to just poke at some easy, low-hanging fruit ideas. Let's look at our heave data and our pitch data, and then let's look at our nadir Z value as well in the same graph. Oopsie. Oh, that one didn't come through. I'll leave that off. You can plot all these things on the same graph. If you get the nadir depth in, you'll see that bobbing up and down. I'm going to try it again. Hopefully it won't crash. Oh, I didn't click across, I think. There we go. So in pinkish, I can see the wobble in the depth. That's my nadir beam, the absolute depth going up and down. It's wobbling. And I can see the pitch and the heave signals, which I've done this for a long time. I'm expecting that one of those two things is driving that wobble. So I can sit here and just do some kind of napkin engineering analysis, some troubleshooting. Try and get to the bottom of that. I can pick these times. Oopsie, that's not what I want to do. I can reposition these and then amplify them a little bit just for the sake of graphing. And I can see, well, okay, my magenta, my depth wobble kind of correlates with blue, the heave. Okay, this is probably a kind of problem. Heave can also correlate with pitch. When I'm pitching, something that's on the end of the bow or something will heave up and down. So that's not surprising either. It tells me, okay, my gut's telling me the right thing. It's one of these two things. It doesn't tell me the exact cause, but this isn't quite the tool for that. This is a useful tool. What I can do is run the wobble analysis tool. This is inspired by John's stuff at UMB that I worked with him for a number of years using these tools and then tweaking them and perfecting them. I decided to try and put that in here. So I'll grab a slice of data on the seafloor, and I can see that wobble. And what John Hughes Clark's tools would do is analyze that wobble and come up with correlation plots, and you'd have to look at them and understand, oh, is that a type 1 or a type 2 wobble? And you can get to that, but you kind of need to be an expert user to really get to that process at the other end and then come away with the result that you need. What we've tried to do is, well, we've hooked up the entire calculation engine. Remember the big dependency diagram with the inputs and the output? Reduced it into a little integrated circuit type idea where there's inputs and there's an output. We stand that up and look at your soundings, and then we let you flick the switches and try stuff until it works. That's something that humans are very good at doing. So I can think, well, maybe it's a lever arm problem. That doesn't seem to have much of an effect. Maybe I got my pitch convention sign wrong. That doesn't have any effect at all. Maybe my transmit sonar beam, the sonar relative, you see the graph updating on it. I'm just trying stuff till it works. And really, I'll just get to the end of this. Maybe the sign convention for my heave is wrong. Oh, there's the problem. That's what it is. People that use GPS hiding are not really using the heave that much. They're recording it, but that's not part of the 3D solution. So this sometimes happens, is that you have the heaves convention sign wrong. You don't even notice it until you switch to tides. So we've just troubleshot. Is that the past tense of troubleshooted? Troubleshooted. I troubleshot that. I can save that and just give this a name and apply it to my files. And it's a dynamic workflow. I'm making a change, and I'm going to see the result as soon as the computation is done. So I diagnose the problem, I trigger the appropriate kind of reprocessing, and once that's done, hopefully it'll look better. See what happens. There we go. Problem's fixed. So that's the dynamic workflow, is you can tinker with things and you see that effect making things better, hopefully. And if it doesn't, like, well, that was a bad idea, let's try something else. That feedback loop is very, very small. Everything updates so that you can get to the root of problems very easily. It makes it much, much easier to troubleshoot data sets. So this is all kind of fun. You can do this in post-processing, but what about doing this in real time? What if you cozy this up against an acquisition system? You're sitting on a cruise for 6 weeks. You know, it's nice to be able to configure this to bring in data automatically and just add it to the map. So this is something that we put into Chimera Live. And it's a capability we've had in FMGT, which we call directory monitoring. It's a much less glorious sounding name. You could point it at a directory and say, hey, bring in files to the project once they get done being written to. And what that does is it gives you a second opinion on your data acquisition system. You get one map in your data acquisition system telling you one thing. Here's a second opinion. And if they're different, you should probably look into why. So that's nice to do, because you're going to, at the end of the day, you're bringing your data project home to work on, not your acquisition system. If you want to, you can get work on validating if you like. If you're deep water cruise and the ping rate's kind of low and you don't have to spend all day looking at the multi-beam, you can start cleaning your data right away. You don't want to get back to the office. The whole point of this is you should know this in real time. This is the reason you do quality assurance in real time. You don't want to be wasting money collecting data that's garbage. You want to know that as soon as possible. So I'll give another sort of a fake demo. I'll pretend I'm offshore. Food's much better here, though. And I'll cook up a little scenario where I add a file to a project and I point it to a directory. So there's one file in there. And that'll come in. Now let's just add that to a map. And what I'll do is turn on Chimera Live. So it's just this one button here. I click this on. Automatic raw file import. It's pretty simple. It doesn't need to be complicated. There's files being generated by an acquisition system, and you just want to pick them up and copy them into the project. Chew them up and add them to the map. So we'll point it to a directory. And I'm just going to copy this path here. Select the folder. Turn that off. Which surface do I want to add that to? Well, the one I already created, dynamic surface. How often do I want to pull the directory for new data? 15 seconds. And it's smart enough to not try and pull across files that are still being written to. So that's sitting there and running. The button's down. That's your indicator that it's running. And what I'll do is I'll just pretend I'm an acquisition system, a much more handsome version of an acquisition system. I just drop files into a folder. So this is where it's looking. I'm just going to step up one level, directory level, and start dropping some files in, pretending the acquisition system is doing this for me. And this is, so depending on where I caught it in the 15-second cycle, this will eventually freshen up and figure out, hey, there's new files, and it'll start bringing them.
So you just put the pointer towards the directory where the acquisitions, the system is going to be.
You can do that if you really want to get really bare metal with the acquisition system. Most acquisition, which is not a great idea sometimes. You want to configure your acquisition system. A lot of them have the capability, hey, when I'm done the file, put it somewhere else. And so they would call that their automatic backup. We recommend pointing to that directory. That way, they're usually on different machines for a lot of reasons, and you can bounce it off the network, and you're not overloading the acquisition machine. So you can decouple it. So there's a couple of do's and don'ts there. So there we go. That just added. So if you're sitting on a cruise with Jim Gardner for 6 weeks, it's an EM122, and it pings once every 23 seconds. Every 6 hours you get a new file. You can just set up Chimera Live in the corner, and it'll just quietly add this stuff. And the map will grow, and it'll grow, and that's all you have to do. If you spend the time to get, usually do with Kongsberg systems,
You can process as you go along.
you can process it as you go along. So if I want to start swath editing, for example, because I'm using a board and the swath editing passes the time, you can do that. You can do area-based editing as well. And it'll bring the files and add it to the project as you go. So there, you can do that in real time. And I got official approval from management to show a new feature that's coming in our next release. So this is going on the internet? Okay, so I'm going to open that same project. In the version that we're releasing shortly. And I want to pitch the idea of dynamic workflow for validation. The analogy I make is, you shouldn't be cleaning your data unless you can see what you're doing. If you went upstairs to, if you have a nursery and you're painting it because there's a baby coming, and would you turn off the lights and paint at night? No, you turn on the lights later and you're like, oh, what did I do to this room? It's the same with data cleaning. You shouldn't be scrubbing your data unless you can see the results. And you should be able to see that in as short a time as possible. You shouldn't have to regrid a massive surface and then come back after 3 hours and say, oh, I didn't quite scrub that data enough. I guess I have to do it again. So you don't want to be painting blindfolded or in the dark. So that's another part that we've done, is trying to make the data I/O very, very fast so that when you're cleaning data, you get that immediate response. So you can tell right away, did I do a good enough job, or do I need to do more? Or did I do too much? So what I'll show is this new slice editor, which allows you to, this is the standard Flater mouse visualization scene here. You've got the terrain model, you've got a box of data, and then a tiny little slice that you slide back and forth. And you can see the point cloud in here. And that's a full point cloud. You can lift up below the surface, and you'll see the points that are below the surface. And if you look at the top, you'll see the points that are on the top of the surface. And that's all in context, so you can make good decisions. And it's all the same vertical exaggeration. So you see the points, and you see the surface. And you can color code these by whatever you like. In this case, it's by bathymetry. You can color code by a backscatter. I was talking to Val earlier. That's a helpful kind of thing. Is this a sound or an outlier because it's a low backscatter value one, or is it probably something real? And you can also keep track of where you've gone. So you can segment the area, partitions. And as you go along, it just quietly leaves a little push broom trail of what you've looked at, and it even shows you what you've cleaned. So at the end, you can parcel that up, see where you've been, and if somebody made some edits, that'll be a different color. So you can just come in and say, oh, who did that? Or this isn't clean enough, and you can go in and just kind of manage that in a little more friendly manner. So I'll demo that now here. So I'll just open that last project that I created, the one with Chimera Live running. Oh, it's off. Luckily, I turned it off for me when I quit the project last time. So let's get to point editing, and there's just one button. Put me in slice editing mode, and let me get to work. So here's an overview map. We've taken the Quincy's ENC engine and put it in here too, so you can zoom out a little bit and get a sense of where you are in the world, which is handy for context. If you're picking a UTM zone and you pick the wrong one, it's nice to know that the first day of the cruise, not the last day. So I can just pick this up and slide around, load my soundings, and this VGA adapters. Does it make computers do this? The flashing? Maybe. Maybe. So I can sit here and just nuke things. I've never done this before. And that's gone. The points are gone from the scene. If you want to hit save, that's gone. The map's updated. I get that feedback right away. I only update the little tiny piece I need, not the whole surface. It's smart enough to know that you only updated this little box. You only need to regrid that box. So I just did a hydrographic sim there. I chopped off part of the wreck. I can look at the rejected ones. Say, you know what, I want to re-accept these. Let's bring them back. Save. You shouldn't be painting in the dark. You should be able to immediately see the impact of your changes. You should know when to stop scrubbing, and you should know that you've scrubbed enough. And since valid aster, you can color things. I don't know if this has backscatter in it. Color by intensity. Oh, I think it does. And I can color by intensity down here in the slice view. I can also do it up here. I can just have the color coding match what I'm doing there. So you get some context. This is kind of boring. This is boring seafloor. This isn't a mosaicing or a geocoder type output. It's the intensity reported for that beam by the echo sounder. There's not really any math being done to it. It's just shown there for context. So that's it. So I'll just wrap up here in summary. I think what we really tried very, very hard to do, we had the technical pieces of gear we needed to build this, and what we really needed to do to innovate was to make this easy for people. I think anybody who's done hydrographic data processing after this, presentation could probably jump into Chimera and just figure it out. We're striving to really just make it deadly easy. These are some of the basic ideas behind that, but if somebody had to sit down and think about that, and then think about what do most people want to do, and how do we control that user experience so that we don't violate the principle of least surprise. We want to get most people to a product that will not surprise them, and then if they know the other things they need to do, they'll go out and find them, the additional correctors, and apply them. But they're not in the way you get in there. It's all hooked up. Really, I think the key point is that a lot of human error, that the frustration when you've had data products and you've wrestled with them for weeks or a month to get them right, that should kind of go away. If you set it up in acquisition right, and you spend the time to get your key personnel out there to shake down the systems, and you have procedures in place to make sure that you did it right, you should reap the benefits from that. From that point forward, you can hire anybody. You can have high school students out for a fun cruise and say, here's how you kill dots. Here's what a map looks like when it looks funny. Here's what it looks like when it looks reasonable. You don't need expert personnel at every stage of the way. So this really could, in the private sector, our clients, they've got to be. They've got a bottom line to meet. Do I need a staff of 50 experts, or do I need a staff of 5 experts and 45 kind of junior level people? You can do that now. It doesn't cost a lot to train them. All that quality assurance burden that you had, the experts that check the work of experts, you don't really need that anymore. You have your experts set it up for you up front, and then the rest of the time it's just pretty straightforward. We're really trying to get the knowledge barrier to entry. You should be able to just jump in and get to a map. Train somebody for a few minutes, and then they can get straight to doing what people do well. It's noticing when things are outliers and that they're not like the others. And at the end of the day, the processing outcomes, you can have results that look right and are probably right. If you give it to the next person, they should be able to get to those same results consistently. Even yourself, that should improve. Post-processing times, you're not spending your time tripping over the methods and the processes and the buttons you have to do. It just shows up and off you get to work. And of course, I think the data validation results are going to be better user experience. The immersive 4D scene from Theranos really lets you make good decisions about data editing. And there's a lot of capability in there in the FM Hydro package that lets you do hydrographic type things like comparison to chart features that I didn't get a chance to go through today, but that's also in Chimera. So that's it. Thank you for your time. Thanks for listening to me. Simon.
Imagine that you have some survey that for some reason you have various special configurations in that same survey. You find that you made some error in entering the data.
From the same platform?
On the same platform.
Yeah.
Maybe in one of the configurations, they're in all the configurations. Do you have some guidance in how to deal with that as well, or is that something where you really start needing something?
Is this something that you noticed, you have an end product, hey, this map looks funny, why is that?
Yeah.
And you've already gotten to the fact that the configuration is different? Or you need to discover that the configuration is the problem?
Let's look at the former situation where you got all the way through.
What we do is, because each of the files codified the vessel offsets, and so if you show up with 1,000 files, we don't want to show you 1,000 time entries in the vessel configuration. That's really tedious. So what we do is, this is one of these crazy words we made up, we uniquify those 1,000 completely redundant entries into a single entry that has the start time of the first unique instance of that. So if you open Chimera and you have a 1,000 files and you go to the best letter and you think they should be all the same, you should see one entry. And if you don't, like, oh, that's funny, there's 2 entries. So you can quickly check that and say, oh, the lever arm's backwards, somebody goofed that up. You can edit it and make it the same, and when you hit save and come back, it gets uniquified to the single instance again, the true calibration, or sorry, configuration. Does that answer your question?
Kind of.
I think I'd have to show you maybe.
Is there some guidance in saying, well, you changed this particular configuration because you noticed this in this data, and it could be somewhere else it's not as obvious,
Yeah.
but it still may be present? Do you suggest, hey, maybe you should look at these files too? Or
Oh, I
set
see.
up to the,
I think what we hope to do is add some little checks when you bring data in. You know, if you're bringing the same files in over and over, and on day 52 you bring in a file that suddenly has a different configuration, we can say, hey, this is not like the last 52 days. Is that something you wanted to do? And then you can say yes, no, and if you say no, you can go fix that. So I think it's very easy with our architecture to add these little checks along the way. That I think on data import, you could catch that before you get to the bad map, and then have to reverse it. That'd be my preferred way to tackle that type of problem.
So I have a follow-up on that. Those questions, they go away after a certain amount of time. Is there a log of those questions so you can see, with this process, I got this question in case somebody just misses the question and they don't answer it?
Sure. There's not a log. We keep track of what you answered. There's a little tick box off to the far right that says "Don't ask again," which, you know, because if you're doing this, I mean, once you've been guided once, you know the way. You don't want to be guided anymore. It gets annoying. So you can say, "Don't ask me again. Just do the same thing every time I bring data." So we remember the answer that you gave if you decided to make us remember. There isn't a log that tells you that you might have missed that. So you still need to, at that point, perhaps trigger that next thing that it was prompting you to do. If it was something like applying tide and you forgot to click yes in time, all of the files that it should be applied to are marked as needing reprocessing. So you'll still notice that things are out of date, and we'll tell you that every time you open the project. And in fact, you can't do anything else to those files until you click update. And
I
then
guess my question was more on if somebody is going back and looking over a project and there's been 8 different people going through
Right.
the project and adding data, is there any way for them to look at, this was a prompt, like, oh, you're bringing in this, did you mean to do that? Is there any way for them to check that?
Not
list?
currently. That's something we could add, though. Yeah. There's a whole other layer of tools that are often needed by people who are paid to check other people's work. Or if you're on a cruise for somebody and you're a client representative, your job is to sit there and just go over their work to make sure that they're doing what they should be doing. So there's a whole tool set that we want to build for that as well. But that sounds like it would fit right in, I think. Dale?
In the logging world, are you keeping a log of what was actually done?
It's a pretty coarse log right now. I mean, the product's 6 or 7 months old, so we're still adding capability. And that's one thing we have on the docket, is to improve logging, to let you do good forensics. When things go wrong and you can't quite figure out what, you should be able to consult the log.
Yeah. Keeping track of what they didn't do is a
You
more
mean-
problematic question.
Yeah.
Keeping track of what the software actually did.
Yeah,
The user
no, that's a really good point.
caused the software to do what the software did by itself.
Yes.
It's pretty important.
Do you plan to bring FMGT into Chimera, or are you going to keep it standalone for backscatter?
We're still not quite on the fence. We're leaning one way. It's a natural home to do that kind of stuff.
Yeah.
We have to figure out a transition plan. And we have many pieces of software. If we think back to IBS and QBS days, this is a name that you're all very familiar with. Here, IBS built that, but the rest of this stuff comes from our colleagues in the Netherlands, and there's an awful lot of tech that's in there, and then in there, and in there, that we need to take out and put into Chimera. So I have a list of things to do for the next 18 months, which is solely bringing out pieces of tech and adding it into there. And
So
FMGT, backscatter processing, is one of those.
Oh, so it's,
It's on our
Within a
list
year or
that
so.
we want to do that. It makes the most sense.
yeah,
It's just a matter of sitting down and doing that and figuring out what the sequence for that. Because that same experience we feel would be extremely valuable.
yeah.
That kind of
Dynamic
magic,
surface
just
concept,
boom, that,
yeah.
they're from the same sensor. You should be able to operate them on them in the same work environment with the same georeferencing and ray tracing problems that you explored on the backscatter. So it makes it really hard to argue to keep FMGT standalone
Yeah.
when its natural home kind of appears to be in there.
A question from the web. Gerard Wati, and if I butchered that, I apologize. It says, thank you for a clear and interesting presentation. I have a question. How easily to correct tide error during a short time via camera?
During a short
time via camera?
the tide, maybe a tide error. Tide should look like that.
How easily to correct a tide error during a short time via camera? That's the exact.
I'm going to guess that he's wondering if there's a tide outage. Let's say you didn't install your tide gauge right and you got an exploded water event and you should have a tide signal that has a nice bottom and it bottoms out. We have a time series editor that lets you fix things like that, and that's all part of the dynamic workflow. When you make a time series edit, it does the magic processing just for that one file. We're still looking to add capability. For example, if I have to fill in the bottom of a cutoff tide, you want to do something like that as opposed to hand digitizing a made-up signal. So we don't have extremely complex tools for that yet, but we're certainly looking at that type of capability for the future. Where's the camera? I hope I answered your question.
Any more questions? Thanks, Jamie.
Thank you.